Welcome to this demo on migrating applications to OpenShift Virtualization using F5 Distributed Cloud. As organizations strive to modernize their infrastructure by migrating applications to virtualization platforms, they face challenges like minimizing downtime, maintaining seamlessly connectivity, ensuring consistent security policy, and reducing operational complexity. Today, we'll show you how F5 Distributed Cloud addresses those pain points, enabling a smooth, secure, and efficient migration to OpenShift Virtualization. Let's kick things off with Red Hat OpenShift Virtualization. It brings your virtual machine workloads into Kubernetes ecosystem. Imagine running VMs and containers side by side, managed through a single platform. This setup not only streamlines operations, but also paves the way for modernizing your infrastructure without disrupting existing services. Now, how does F5 Distributed Cloud, F5XC for short, fit into the picture? F5XC secure multi-cloud networking acts as the glue during your migration journey. By connecting apps across clusters, it keeps your VMware and OpenShift environments communicating during migration. It allows for gradual shift rather than flipping a switch. It ensures consistent application security during and after the migration. In essence, F5XC helps you migrate with confidence and minimal disruption. In today's demo, we focus on managing the Layer 7 services during this migration. So we'll demonstrate how quick and easy it is to use F5XC to facilitate this migration through 3 simple steps. First, we configure F5XC CE to serve VMware-hosted apps to the users. Then, migrate the VM using Red Hat Migration Toolkit for migration. Finally, we switch traffic smoothly, transition traffic from VMware to OpenShift, ensuring minimal downtime. This approach isn't just about moving VMs. It's about ensuring user experience remain uninterrupted throughout the migration process. Let's see this in action. First up, this is a typical VMware NSX environment. This is our starting point. VMware hosting our critical applications with NSX to provide security and networking for the applications. Let's check out a VMware NSX cluster. We have NSX Tier 0 and Tier 1 logical routers. We also deployed a couple of virtual machines running the Juice Shop application to showcase our current workload. We also deployed F5XC Customer Edge, CE for short, is up and running, ready to facilitate the migration. Now, for each tenant, we deployed one F5XC CE running inside the VMware for tenant isolation. Moving on, we are going to configure F5XC CE to serve the VMware-hosted apps to the users. First, let's take a look at F5CE VMware side in action. Switching to F5XC console, we navigate to Multi-Cloud Network Connect to view the site status. Here we can see various metrics indicating the health and performance of our site. As you can see, the site is up and functioning well. This confirms that F5XC CE is properly set up in our VMware NSX environment. Next, let's get our Juice Shop application out to the internet. This is as simple as configuring a load balancer, pointing origin to our VMware environment. Let's review the setting. We configure the HTTPS with automatic certificate management. We also enabled redirect HTTP traffic to HTTPS. To further secure the application, we also deployed Web Application Firewall configure the bot defense, enable the DOS protection. With these measures in place, our Juice Shop application isn't just live, it's secure and resilient. Let's take a look at the Juice Shop application in action. We just go ahead to open a browser and navigate to the URL. As you can see, the app is up and running. Users can interact with the app just as normal. This confirms that our pre-migration setup is operational. Now, suppose our enterprise have decided to migrate the Juice Shop application from VMware NSS cluster to OpenShift Virtualization cluster. We'll use the Red Hat Migration Toolkit for Virtualization, MTV, to migrate the app. Then we will leverage F5xCCE to test and also switch the traffic. It's worth noting that the OpenShift Virtualization cluster is utilizing the same IP address, so this will help in preserving the IP addresses during the migration. Switching over to the OpenShift console, we can see that we have an OpenShift cluster running on bare metal. We will install two operators, the OpenShift Virtualization operator and the Migration Toolkit for Virtualization operator. We'll leverage the MTV to migrate the VMs from VMware to OpenShift in a few simple steps. For the detailed steps, please check out the OpenShift migration guide. In our case, as you can see, we have a test VM1 and test VM2 successfully migrated to OpenShift Virtualization. Mission accomplished. Just like what we did in VMware, we deployed F5xCCE in our OpenShift environment. Let's take a look at the F5xCCE site for the OpenShift. Back to the F5xC console. Again, we navigate to Multi-Cloud Network Connect to check the status of the OpenShift site. As you can see, the site is up and functioning well. To include our migration app in the load balancing setup, we will add a new origin pool. Go to the origin pools section in F5xC console. Reference the app's IP address for the CE site. In our case, is the OpenShift site. By doing this, we're setting up OpenShift hosted app as another backend for the load balancer. With the new origin pool added, we'll return to our load balancer to associate the pool. Navigate to the load balancer section and select our existing load balancer and the origin pools. Add the new pool we just created. We also configure the weights and priorities to manage the traffic between the backend origins. This setup allows us to control how the traffic is distributed between the VMware and OpenShift environments. With the new pool added and configured, we're now load balancing our application between VMware cluster and OpenShift Virtualization cluster. We can adjust the weights and priorities to gradually decrease the traffic to VMware host application. Eventually, we can disable and bring down the VMware hosted application without any disruption to the users. Let's return to the Juice Shop application to verify the load balancing is working. We open the browser and refresh the application multiple times. We expect some requests are being served from the VMware and others from OpenShift. User continues to have seamless experience. Back to the F5xC console, we can review the application performance metrics to verify the requests are being handled as expected. Go to the Observability section and select Requests. After refreshing the page, we can see that the origin server details have changed, indicating that the request now being redirected to OpenShift hosted applications. This confirms that our migration is on track and the user experience remains unaffected. This concludes our demo. We'll successfully migrate our application from VMware NSX to OpenShift Virtualization using F5xcce. Here's what we accomplished. We maintained the connectivity between the two clusters by preserving the IP addresses during the migration. We gradually shifted the traffic without any downtime. We also ensured application security throughout the process. Thank you for your time.